Okay. How many on O? Okay. As long as you got 6 dots, it's okay. I drew it correctly, but if you didn't, it's all right. All right. What's CS going to do? It's going to lose 1. And where's it going? To O. I was going to say, we don't have an S. All right. So O is going to have how many now? Is it going to be happy with a 7? No. So we got to add another what? CS. And so CS is going to lose 1. And where's it going? To the O. So we have now what? So -2. Now, if you had trouble figuring that out, you could say CS has what oxidation number? 1. And O has what oxidation number? 2 and 1. So that means you're going to need how many CS's and how many O's? 1. So that'll tell you how many of each of these you got to have on each side, right? Okay. Yeah.
Does it matter when we put CS's?
You could have 2 CS's first and O last. Doesn't matter the order. All right. So the last thing we need to do is balance. So how many
2
CS's over there? So I need to put a 2 right there. Everybody okay with that?
Yeah.
Okay. So how many AL dots do I need? 3. All right. How many F dots do I need?
7.
All right. So AL is going to do what? Lose 3. All right. So AL is going to have a +3. And F is going to have how many on it?
8.
Okay. So it gains 1. And so I got 2 homeless dots, right? I can't have homeless dots, so I got to add somebody. Who am I adding? Adding an F, and F can take how many? Can take 1. So that means I still have a homeless dot. So put 1 more F. And that F can take what? 1 more dot. So now, to balance it, I need to put a what? 3 on the F. Any questions about how to do that? All right. What's the major difference between ionic and metallic bonding?
Metallic bonding, the electrons are like freely moving around.
Yeah.
Wait, your metallic bonding what?
The electrons are, what'd you say, Tomas?
Moving around freely.
Moving around freely.
In metallic?
Mm-hmm. It's the only thing we talked about yesterday. We haven't really talked much about ionic, but that's going to be the big thing that I'm going to talk about today. The electrons are freely moving in an ionic bond. They're not moving. Sorry, they're freely moving in a metallic bond. They cannot move in a metallic or in an ionic bond. And I warn you, I do not feel well today, so there's no telling what I'm going to say. Hopefully, it will not sound ridiculous. All right. Can we look at some homework and see what kind of questions we have? Okay. All right. So in part A, you're supposed to tell me if it's ionic or if it's covalent, right? So in number 1, if electrons are shared, it's what kind of bond?
Covalent.
It's covalent. In number 2, if electrons are transferred, it's what? It's ionic. All right. In 3, if it has a triple bond? Covalent. If it has molecules? Covalent. If it has positive and negative ions? It's ionic. If it's a metal and a non-metal, it is ionic. If it has 2 non-metals, it is covalent. If it has polyatomic ions, if it's within polyatomic ions, like SO4, or, for example, if it had like SO4 -2, or NO3 -1, or PO4 -3, or NH4 +1, any of those, what would it be? All right, most of y'all are saying ionic, and that's why I wrote these up here. Okay? What kind of elements are in those? They're all non-metals, right? So if they're all non-metals, what would it be if they're all non-metals? It's covalent. Okay? It's all non-metals. That's why it's covalent. All right. Trigonal planar shape. Now, trigonal is just another way to say triangular. Some books will write trigonal instead of triangular. It means the exact same thing. So just translate it into triangular planar shape. What does it mean to say triangular planar shape? What had triangular planar? Was it something we identified with an ionic bond or a covalent bond? It was covalent, okay, because it had to have covalent bonding. It had to have a Lewis structure. And 10, resonance. It was covalent because it was two different ways to draw a Lewis structure.
I didn't know what resonance
Meant two different ways to draw a Lewis structure. So like in your SO2 down there, some of you probably put the double bond on the left side, and some of you probably put the double bond on the right side. That would be a resonance structure. All right, if you didn't draw a double bond, then you didn't draw it right. Number 1, who would be bigger, the F with the minus or the F? Oh, sorry, it said smallest. Who would be smallest, the F with the minus or the F? The F. Okay, who would be smaller, B plus 2 or BA? The plus 2, because it means you lost 2 electrons.
circle the largest one.
Oh, well, then go back and circle all the other ones because they said smallest. I did the same thing when I started calling out the answers. The question said smallest. All right, O minus 2 or S minus 2? Hey. Yeah, I altered the plan towards the end, though, because they were all sort of laid out on the stairs. Yeah, but watching those people dance and learn the dance moves, I said, how about we go back and do Seize the Day and we impress Ms. Rector because we know something when she comes back. So we worked on Seize the Day, didn't we? So they were doing pretty good with Seize the Day at the end. They said that one was easy. So she wasn't doing too bad. They were doing pretty good with Seize the Day.
They thought when they started seeing the moves for Seize the Day.
Yeah.
It was like, we're not doing that.
Yeah. That last one though, they were like, oh, I don't think we can do that one, Ms. Rector. So O minus 2 and S minus 2. O minus 2. And K plus or NA. Because they're in the same group. So what happens if you're in the same group? It's because they get bigger as you go down. So whoever's further down is going to be bigger, and the question says smaller. So same thing in 4. You got Na at the top and K further down. So what happens as you go down? You get bigger. So who's going to be smaller? Na. All right. So the part C I have on the board. I'll pull that up in a minute. All right. So D, number 1. What geometry did you say that was? Tetrahedral. And 2, bent. And 3, triangular planar. 4, 5, and 6, bent. All right. On the back, number 1, what bond type? Ionic. And 2, yep. And 3, polar covalent. And 4, non-polar covalent. 5, I actually landed on the line. You could tell me either one and it would be fine. You could tell me ionic or polar covalent and I would not count it against you. And then 6, polar covalent. Any questions about any of those? Because the other ones I need to show the answers on the board. Okay.
So if it's asking for the type of bond, like the electron.
If anytime it says bond type or bond polarity, you've got to subtract and use the electronegativities. If it says molecule polarity, it's asking you to use, or if it just says polarity, it's asking you to use the 2 rules of the Lewis structure. But if it says bond polarity, it uses the word bond specifically, it's asking you to subtract. All right, so 2 of these should have been pretty easy. The S and the Na are normal dot diagrams. The others are going to cause issues for you. So let's talk about those real quick. All right, because Xavier came by this morning. He was like, well, I have no idea what you're talking about. So there's bound to be a few others who are in that same category.
How do you know if it's polar or not?
for polarity. If it has dipoles and like the same element going around it, and if it doesn't have lone pairs.
Yep, on the central line.
So if it has all the same elements, it's polar.
It's like if it has 3 elements, it's polar.
We'll talk about it on the next slide. All right, so if you look at your dot diagrams in the first row, sulfur has 6 electrons. So the first picture has 6 electrons. Na has 1 electron, so it has 1 dot. Ones that cause issues are the ions. All right, nitrogen has 5 dots, so I drew it with 5 dots. The red is the 5 dots. But it didn't say an atom of nitrogen. It said what of nitrogen on your worksheet? It said an ion. What's an ion?
Atom with the charge.
An atom with a charge. So what charge or what oxidation number does nitrogen have? Now plus 3, minus 3. So the minus 3 means what? It gains 3 what? Electrons. So gains 3 electrons. So up here in blue, I drew in what? The 3 electrons that it gains, and I wrote minus 3 on it because it gains 3 electrons. Does that make sense? Okay. At the bottom, zinc has how many electrons? All the transition elements have how many electrons? 2. The oxidation number for zinc is what? Plus 2. So what I do with those 2 electrons if its oxidation number is plus 2? I lost them, so did I draw them if I lost them? No. I just wrote plus 2.
So how will we do that on the quiz, like drawing in if it says?
I wouldn't ask you to do that on today's quiz. I'm just showing you that in case you see it on the test next week. Okay? The quiz is that. Okay? Being able to do that is the quiz.
Oh.
This is just for the test. This isn't on the quiz today.
So basically the majority of the quiz is drawing Lewis structures.
I told you, it's Lewis structures. Tell me the geometry, determine it's polar or non-polar. There's nothing on it besides that.
And
This is on the test.
what sheets?
If you'd like it, you may have
What sheets are we allowed in?
it. A periodic table.
And that's it. Oh my God. Which period?
You can have any periodic table you want. Well, your orange one or your electronegativity table. Most people use their electronegativity table, so they have it if they want it. All right, so if we look at your third or your second row, some of you left those blank because you were like, I didn't know how to do that, or I just didn't do it. There are your chemical reactions for ionic structures. So you can see that Ca loses 2 electrons, O takes them. Na loses 1, Br takes it. And then the next 2 aren't even switches and required balancing.
I got it right.
Good.
I'm so smart as well.
I agree with you. All right. Any questions about the second row?
No.
No.
Wait,
No?
do we have to put the plus 2 minus 2 on the numbers?
You need to write in the oxidation numbers, yes. Okay, because that tells us how many electrons were lost or gained. So yes, you need to write those in. Any questions about the chemical reaction part for the ionic structures? All right, and then the third row was the Lewis structures. Now, no, on the test, yes, not on the quiz today. No, the quiz today is this. Being able to draw those and then telling me their geometry and whether they're polar or non-polar. So like in this first one, what's the geometry? How do you know it's bent? You got 2 oxygens and how many lone pairs? 2 and 1 is bent. Is it polar or non-polar? All right, how do we know that, Jade?
If it has the same elements.
All right, S and O, that's rule 1. So we got dipoles are equal. We have lone pairs. So that means rule 2 is a no.
Okay, I have a question.
So that makes it polar.
Some of them, the elements going around, it doesn't have 8.
The only ones that we've learned that don't have 8 are hydrogen and boron. So like this H won't have 8. That's an exception.
So everything else has to have 8.
Boron the same way.
Boron will only have 6. Those are the only 2 exceptions I told you had to know.
I got a question.
Yep.
Why did you do double bond?
Because that one is a resonance structure. This one is correct. This one is correct. You can do it either way. Both of those have 16 electrons, and both of them have 8 on each atom. Which way did you draw? You have sulfur and not, oh, you have 20 electrons, not 16. 18, sorry. Not only as of 18, you have 20. All right. The last page, the very back, just wants you to know polar, non-polar. Didn't ask you to do anything else. So this is where you have to use the two rules. So when you look at SeO2, do you have the same bonds?
Yeah.
Yes? Do you have lone pairs?
Yep.
Yes. pH3 is that exception I told you about yesterday. I have not put any weird exceptions on the quiz.
Wait, what was the exception?
Where you subtract and get 0. Even though it has lone pairs, if you subtract your electronegativities and get 0, it's going to be non-polar regardless. Okay, but I didn't put anything weird like that on the quiz.
Wait, I'm confused.
If you look at P,
even if you have the molecular polarity, you still have to subtract.
if you subtract and get 0, and you have lone pairs, it won't be polar. You have to have a dipole of at least 0.1, which is why I didn't put that on the quiz. I'm not trying to trip you up.
But I'm saying we still have to like subtract.
You would have to check, yes, every time.
Okay, I have a question.
Yep.
So I know in bond polarity we use
chart.
these.
Mm-hmm.
Okay, so in molecular polarity you use.
Technically, you're supposed to check every time to make sure it's not 0. But I'm not trying to complicate life for you. Like I said, I didn't put any weird exceptions on the quiz. All right, and SF2, again, the bonds are equal, but you got lone pairs, so it's polar. And same thing for CH4. Bonds are equal, no lone pairs, it's non-polar. Other questions on the homework or finding little structures, geometries, polar, non-polar?
No. Linear.
What? Yeah.
All right.
All right, anything else? You need a periodic table so you can find your number of outer shell electrons. If you want your electronegativity table, so you have that, use that one. If you don't want that one and you want to use your orange one, that'll be fine too. You can use your orange one. What's wrong with you?
I feel like I just took like a gloss on that's only.
I agree.
Is it okay on the test if we just draw a triangle and then write?
Yep, you can write triangle and then planar triangle into your middle. I'll be fine. Scott?
Okay, I have one question before you give out the test.
Yeah.
Okay, the other bent, it has just, it's a O with the sheet you gave us.
It's 2 and 2 or 2 and 1.
It's
It's
H2O.
yeah, it's 2 atoms and 2 lone pairs. That's the homework I checked. That's the homework I checked today that you need to do. Got it. That was homework I checked today at work.
So your mom has to work. Your mom has to work.
Now, make sure if you're writing in ink and you erase dots, that they're gone. Okay? As you shift dots around, I need to be able to tell that they're gone. Are you taking it or making it up? Okay. Eduardo, were you taking it or making it up? I didn't think to ask. What? Okay. Right? This is one I recommend you do in pencil. On your desk. I forgot to use phone back. How many of you are still working on the quiz? So I like it. Who's still working now? Anybody? Don't see any hands. Really? So, all right, extra paper's still fun. Does that mean you learned it so well, we're all good? Man, you were so good. So I'm gonna be very pleased if I grade these.
Might be.
Or I'm gonna be so silent. I'm gonna be happy
Should
Some
be.
of them here.
on some of them, on some papers or some questions.
Some places.
That doesn't instill me with confidence.
I mean,
I mean,
hey, It's one of the columns I was in here though.
Just one column,
Just one column.
like the drawing column, or like the polar, non-polar, or the geometry column.
A little bit of the
I
geometry.
got all different ones.
But I feel like actually, I'm.
You got the column rainbow?
She said that.
No, I said, I didn't say,
Oh, good.
She said it was like.
oh, that one right?
Okay.
That one right?
Okay, good. They back there finally did it.
Oh, I did.
You said we done for class for today?
Oh.
Even if I feel like crap, we're not done for it. Don't apply. All right, find your notes.
We want you to feel better. Oh, it's a chicken soup.
I wouldn't feel like crap if men would do their.
Oh, shoot. She knew it back a little bit.
Well, I was gonna say, if he'd gone to the doctor at the beginning of the week like I told him, he would not have given this to me. So now he's at the doctor today. And he should have been at the doctor Monday.
He decides to go to the doctor once you have it.
Once I had it and I'm pissed.
She's pissed. I'm pissed. I don't even.
Me too. I don't want to have a respiratory infection.
Who has a respiratory infection?
I'm pretty sure I do.
That's disgusting.
Yeah, it is.
You got bronchitis.
Well, I'm pretty not.
Have you ever had
I
bronchitis?
follow Miss Thornhill's plan. I'm popping juices up and drinking water like crazy.
No, you want to
No Pepsi? No, I'm supplementing with Pepsi. Well, I should say I'm supplementing Pepsi with water.
What's in that video?
Pepsi, but I'm drinking water too.
You drink Pepsi every day.
Oh, yeah.
Coca-Cola's
I don't
better.
like Pepsi or Coca-Cola.
Ow.
Now you don't sound like Coke. I won't drink Dr. Pepper. I won't drink Cheerwine. I will drink Mountain Dew if I get too ingested.
Sprite is better.
Ow. Ma'am, can I get water?
Yes.
Oh, man.
All right. All right. Let's see here. We don't need any of that. Let's get rid of that. Hold on.
Was that the longest notes for the categories?
I will probably be just about as long.
How long is this test?
I don't remember if it's 78 or 79 questions.
Oh my God.
We
That's pretty long.
got two class periods, you said?
I hate the way mine
You got some paper?
I might have one package left. Let me look. I don't have much left, but I might have one package.
I'm glad I got a dime. I think you put your room. I feel that brown. Which guy?
Yep, this is it. Last package.
I don't know, I just feel like that.
So they put school supplies on sale next August. This is all I have. Because I won't buy it at the high dollar price. All right. So yesterday, we talked about metallic bonding, right? So, shoot, I meant to bring that 9-volt battery.
Do we write this if we already?
Yeah, I'm just gonna put a couple highlights here. So, what do we say about metallic bonding that's key to metallic bonding so we can compare and contrast it to ionic and covalent today? All right, so the electrons move. All right, what else do metallic bonds do that will be different from ionic and covalent today? They're what? They're good conductors. All right, they're malleable. They're ductile.
Lustrous.
They're lustrous. Now, do we remember what those words mean?
Yeah.
All right, malleable means what?
Rolled into
Rolled into sheets, okay? So somebody asked me, I want to say it was,
What was this period?
I don't know, it might have been third, no, could be about fourth period. For some reason, I think it might have been talking about the fourth period yesterday. Those aluminum foil only came in really thin sheets. Aluminum foil, or aluminum really can come in anything. It can come in little balls, it can come in thick pieces of metal, it can come in anything. But the reason that we have it in those sheets is that's just what most of you are familiar with, because most of us have aluminum foil and open a cabinet or a drawer because you use it all the time. But aluminum can be used for bicycles. We could use it for siding on planes. If we're using it for a bicycle to make bicycle parts, is it that thin? No, it can be much thicker for what we need. Okay? What?
They have bats made out.
They have bats made out of aluminum. Okay? So aluminum foil is not just used to make aluminum foil. We use it for lots of different things. Aluminum foil is just something most of you are most used to. Now, somebody asked me, and again, I don't remember what class this was in, a lot of really old people will call it tin foil. USO, okay? And that tends to be an older person kind of comment. You don't hear a lot of younger people calling it that unless you've spent a lot of time with older relatives. All right, what does it mean to be ductile?
Drawn into wire.
Drawn into a wire, and then lustrous means what? Shiny. And metals are lustrous or shiny because even though they come out of the ground, they might not be very shiny. They can be buffed up and made to be shiny. And once they've been made shiny, they stay shiny. Now, things that are in like group 2, like manganese, we can make this look pretty shiny for a couple moments, a minute or two, and then after a day, it's going to do what? It's going to get this black coating on it like it has here. It's not going to stay shiny. You would not want a manganese ring because it would get ugly after you had it against your skin for a while. Okay? So, also, we said this was the strongest bond, right? So, if it's the strongest bond, what do we know about its boiling point? It has the highest boiling point. Now, this will be important when we get down to boiling point down here. Okay? Now, let's talk ionic bonding. Okay, ionic bonding. Now, we said that ionic bonding, the electrons are shared, right? Sorry. Electrons are lost or gained. I'm already jumping to the last kind of bonding in my head. Okay. The electrons are lost or gained. Now, the thing about ionic bonding is ionic bonding tends to be crystals. So, everybody at some point in your life has maybe had rock candy. Maybe you got really lucky. Not many teachers do this anymore, but maybe you got lucky enough that you had a middle school teacher or an elementary school teacher, and you got to actually grow some crystals. Okay, you had a liquid, and you put a paperclip on a string, maybe, or a toothpick on a string, and you submerged it in the liquid, and you tried to form crystals on the string or the paperclip. Anybody get to do that? Maybe in elementary or middle school? I got a couple hands, all right? Typically, not a lot of people get to do that anymore, but it used to be an activity most people got to do in elementary or middle school. No, we're not. Say what? Made a snowflake ornament? Okay. It used to be something that everybody got to do, but unfortunately with time and math and reading being such a focus, science just got compacted to the bare minimums, and that just got one of the activities that's been chucked over the years. So virtually nobody gets to do it anymore. But if ionic bonding is mostly crystals, what state are ionic compounds going to be in? They're going to be solids, okay? All right, ionic compounds are going to be solids. They're going to be crystals. Now, to illustrate the difference here, now, ionic compounds are going to have one of 7 geometric patterns. And when we talk about solids and liquids and gases, after we do the gas laws, which is next, I will come back and talk about those 7 geometric patterns in more detail. I'm not going to spend a lot of time with that today simply because I don't want to burn a lot of time with it. But I'll come back and talk about the 7 geometric patterns that all ionic compounds have. For today, I'm going to talk about one. Okay. Okay. Cubes. One type of crystals is a cube. So, y'all know I can't draw. Nothing's changed. So picture this as a giant cube. All right, this whole thing is called a crystal lattice. Now, make sure I didn't skip what I wanted to yesterday. I don't think I did. Yeah, I didn't. Okay. Okay. All right. So this whole thing is a crystal lattice. All right. And if I drew better, it would look better. But it's just an orderly arrangement of crystals. Now, in a crystal lattice, you're going to have a lot of different crystals, right? Are all the different crystals going to have different types of crystals, or are they all going to fit one same pattern? The same pattern, okay? They all have the same pattern. They would repeat, which is why it's a shame y'all don't get to grow crystals anymore, because you would be able to see the repeating pattern if you actually got to grow these. Because it starts as one crystal and they multiply out from that one seed crystal. That one crystal replicates over and over and over again. Okay? So, this one crystal right here is called a unit cell. It is the simplest crystal. And it tells the shape of all the crystals. So if I know the shape of the unit cell is a cube, what do I know about all the other crystals in this crystal lattice? They're all what? I heard it. They're all cubes. Now, there are only 7 patterns. One of them is like hexagonal for ice. Ice is a hexagonal cube. So once you make one crystal that's hexagonal, what do all the other cubes start to form? Hexagonal. Okay? One of them, I can't remember if it's the emerald. One of them is orthorhombic. All right? And you're never going to have to learn the 7. There's just 7 of them that I'm going to show you in the book. All right? One of them is orthorhombic. Once you form that orthorhombic crystal, all the rest of them around orthorhombic are orthorhombic. Okay? They just form that. Now, does everybody have what they need off this board? Do I need to wait?
Yeah.
Okay. I'm going to put water over there. You look like a lizard laying out in the sun, sunning themselves in the summertime. Just laid out, waiting on the rays. I know. I would love to go home and check it out.
I'm not gonna 30. I didn't even realize I'm going to
That's why we don't get out at 3:30.
Right. I'm going to this.
All right, everybody got it.
Oh, yeah.
All right.
I'm sorry for the teachers. It's no stay. I'm going.
That's something great to do, actually.
All right. Every crystal has a lattice energy. The energy needed to break the bonds in the crystal. Okay, it's the energy needed to break the bonds in a crystal.
Aren't lattices like the things that you put,
Crystal lattice. So,
what is lattice?
aren't lattices the wooden things?
can be. It's just the word that they use to talk about the structure of the crystal, the way it's held together.
Hey, go back.
I am. You want to know what lattice was, so I just went back.
Thanks for
Okay. So, if you think about when we talked about bond energy, what did I say about bond energy? The more energy, what did we say about the bond? The stronger the bond or the weaker the bond? The stronger the bond. So what would happen with lattice energy? The higher the lattice energy, the stronger or weaker the crystal? The stronger the crystal. You might see a question about it, yes, which is why I'm pointing it out. I cannot remember in 79 questions which ones are there, but I want to say that yes, I have something about this on the test. There's a lot.
You said we got 2 class periods.
I did not say you have 2 class periods. Xavier keeps saying there's 2 class periods. There's 1. All right. So now, what can you tell me about the electrons? Can the electrons move?
Yeah.
If they're in this crystal lattice? No. The electrons can not move. They are locked into the crystal lattice. So if they're locked into the crystal lattice, what kind of properties will ionic compounds have? Can they conduct?
No.
No. Okay. They cannot conduct. All right. Are they malleable? Can their electrons move out of the way if somebody hits them with a hammer? No. Okay. They're not malleable nor ductile. All right. So if they're not malleable or ductile, what happens if you hit them with a hammer?
Break.
They're going to break. So we say that these are brittle. Okay? I heard somebody say shatter. Things that shatter are brittle. All right. Comparing the strength of the bond to ionic or covalent and metallic, where do you think they fall? Are they strong or weak bonds?
Strong.
They're strong. Okay, they're strong bonds, but they're not as strong as who? That's right. Not as strong as metallic. All right, now let me see what I've forgotten, because I feel sure I've forgotten something today. All right, we did that. We did that. Why would we put that there? But I guess I can. Oh, I didn't do that. All right. can I make it conduct?
No.
Yes.
If the electrons do not move.
Oh, no.
Hold on. In order to make something conduct, all I need to do is get the electrons to do what? So can I get them to move?
Yeah.
Maybe.
If you break it.
How can I get them to move if I break them? Is there a method I can get it to move?
Break it away. Put them small pieces.
What was the last one on that list?
Okay.
No.
You stay over there, all right?
I was just asking you, see what you were trying to
I
say.
ain't having,
Why are you two yelling at each other?
I'm not yelling at her, but if she wants me to get.
I'm going to tell Miss Burton you two need some anger management classes.
I don't need no anger management. I'm not angry. We're not angry, yeah. I'm perfectly fine.
Mm.
Me and Jay just have a strong relationship. That's what I like to call it.
Can I get ionic compounds
We're not friends.
to conduct?
No.
Okay. All right, you said if electrons move. So, can we get the electrons to move?
Yes.
Break it
Yes.
into small pieces.
All right, well, just chop it up. Like if we take a cube of salt and we chop it up with a hammer, that's not going to help us.
Chop it up.
We heat it up, it'll do what?
I don't know.
It'll do what? I heard it.
Milk.
It'll melt.
And then it'll.
If you melt it, we'll refer to it as the molten state. Now, I can't do that in here. I don't have a Bunsen burner that will get hot enough to melt salt. Salt has something like, I want to say 860 degrees Celsius for a melting point. It's pretty high. I cannot melt salt in this classroom.
What's that in Fahrenheit?
Like a sample of salt in a Bunsen burner or on a Bunsen burner, and we would be able to melt it. Now, those of you who may one day major in science, if you have to take a chemistry class for your degree program, you may do a lab where you have little samples that you put them in little glass tubes and you put it in there's a machine in most college chemistry labs where you just put these little tiny, I mean, they're slender. It looks like little needles of glass in these in this machine, and it'll raise the temperature up. And when it hits this melting point, it'll instantly melt whatever that compound is. And salt has a really high melting point. But I don't have that piece of equipment in here to demonstrate that. So I can't do that. Is there another way that we can make those electrons move? It might be easier. I do it all the time in my house.
Cook it.
How? What? How? Yep.
Whoa. Hey.
What are you doing?
Okay. Now, when I do it, it's more for taste than anything else because I'm the primary cook at my house and we boil water a lot for noodles and various other things, but we do it for taste. I put a little salt in the water. Well, when I put salt in water, the salt generally does what? It dissolves. Now, it doesn't melt, it dissolves. Now, if I put some salt in water, I create Na plus and Cl minus. These Na plus and Cl minus, these are moving ions. These moving ions are your moving electrons. They carry the current. That's why in summertime, if you're in a pool and an electrical storm or lightning storm, thunderstorm comes up, what do you have to do?
Get out of it.
You got to get out of the pool because every single pool dumps what in by the bucket full?
Chlorine.
Chlorine. That chlorine does what? It dissolves and it conducts electricity. So if it's hit by lightning on one end and you're at the other end, what happens?
You done got hit.
You're going to die. You're going to
You done got
die of a massive jolt of electricity. It's why several years ago, a young lady was killed in a swimming pool. Okay? It was a tragedy. Unfortunately, electrical current traveled through water that was in the ground. It was able to reach the swimming pool. Once it reaches the swimming pool, there are all these ions circulating in that swimming pool. Once it reaches those ions are moving everywhere from one end of that pool to the other end of that pool. It doesn't matter where you are in that pool. Okay? That electrical current is going to travel. Okay?
Okay, I got so you know how when she grabbed that metal bar, that's when it killed her or whatever. If she would have got off on the side, would it still have killed her?
No, other people did. They felt the tingling in the water, but they went off on the cement and they were okay.
Wait, what was
It was at
Brookside.
Brookside. Whatever I mentioned.
when?
Mhm,
Couple
2013, I think.
Yeah, a couple years ago.
About 4 years ago now.
What if, so would it be the same if somebody had you don't sound stupid. What if they had a saltwater pool? Not saltwater, but you know, like the pools that they're chemicalized by salt.
Yeah.
Like they're cleaned by salt.
Same thing.
So what if you don't put fluorine in the water?
Doesn't matter. Water itself is called autoprotalysis. Water self-ionizes into ions.
Right.
It will not be as strong, but water forms ions on its own. Secondly, the state of North Carolina puts chlorine ions in the water to kill the germs in the water. Not as strong as a chlorinated swimming pool. We also put fluoride ion in the water in the state of North Carolina to help our teeth. Not all states do, but North Carolina does. If you have copper pipes anywhere, you're going to get copper ion in the water. We've taken lead out of the water because we've hopefully converted all of our pipes so we don't have any lead in the water. But there are ions naturally in the water. So if you're in any kind of water during an electrical storm, you will be electrocuted.
Including the shower.
Yes.
All right. So how close would you have to be? Like, say you was in the ocean and like it's lightning. How close would it be for to affect you?
It will dissipate over a large area. So, I mean, if you're multiple miles away, you'd probably be fine. But I don't recommend being in the ocean during an electrical storm
What if
either.
you're in a boat?
That's salt water. What?
What if you're in a boat?
Where?
Hopefully you'd be grounded, but again, I wouldn't recommend being in a boat during an electrical storm.
So, if lightning strikes the ocean, Pacific Ocean, the whole ocean turns into a storm of
No. It will dissipate.
Did you know what
So does it not kill animals if it did hit the ocean?
They're able to withstand that.
What was the one thing?
Huh?
On the bottom right corner?
It was like 4 down here. I was on the channel.
Oh, thank you.
All right. Now, covalent compounds.
This one isn't as long as the other one.
No, covalent compounds are the short one. Now, covalent compounds do what with their electrons? They share electrons. All right, covalent compounds share electrons. They have no ability to form ions. The electrons do not move. So, if the electrons do not move and they cannot form ions, if they can't do those two things, what can you tell me about covalent compounds? They can't conduct. Okay? They cannot conduct. Okay? Because of the fact they have no ions and the electrons do not move, they cannot conduct. We cannot make them conduct.
How do squirrels and birds can be on the line? Yeah.
I don't think they're actually touching something that will electrocute them.
Right.
If they actually touch something that has juice running through it, they can be electrocuted. Because I know people who live near power lines, and periodically squirrels fall off and they're laying there dead with their feet in the air. So
That's not.
I know. I know they do periodically get electrocuted.
Right, I saw one.
I won't try it either because I barely eat it.
Right.
I know some people do.
Yes, I know someone who eats squirrel.
I don't know.
But
Country bumpkin.
Right.
I live in the county, so I know people who eat those things.
Gave my godbrother gave.
All right, moving on. And we're not going to talk about people who eat what I consider rodent. All right, they cannot conduct. What else? Are they going to be malleable or ductile? No. Think about it. Covalent compounds are going to be all nonmetals, right? So these things are going to be gases and largely liquids. Fix that. Okay, there will be some solids. All right, now, because there are some solids, mostly gases and liquids, all right, they're going to be what we call volatile. These evaporate easily. Okay, they evaporate easily. There will be an occasional solid, but most of your covalent compounds are going to be gases and liquids. So those of you who are planning to have your nails done today, if you have any nail polish still on, what are they going to have to do? Remove it. How long does it take for that stuff to dry? Instantly. That's a volatile liquid. It evaporates easily. If any of you have to go to the doctor and they rub your skin with alcohol, how long does it take the alcohol to dry? It's instant. That's a covalent compound. It's very volatile. Okay, that's a volatile liquid. We know they're not going to be malleable, ductile. They can't conduct. These are going to be the what type of bonds? Strongest or weakest? These are the weakest. So if they're the weakest, what can you tell me about the boiling points? This will be the absolute lowest boiling point. Okay? Questions?
I have a question.
Yeah.
So when I was little, I had warts on my face, and I went to the doctor. They were freezing them off with that stuff. But when I poured it on the floor, it just disappears. What is that?
My guess is it was some type of liquid, hydrogen or nitrogen, something like that.
That's right. It was freeze my fingers. It
Yeah, liquid nitrogen would be my best guess.
That's usually what they do.
Yeah, like that compound W or whatever that you use for
You
water.
can't consume that. How did they?
All right. So the last thing we have to do, and we're probably going to have to finish this a little bit on Monday, is van der Waals forces. But we can at least get everything written down. Now, these are forces of attraction. I want you to think of these as little bitty magnets. Okay?
Is this still with the covalent or is it separate?
This is still covalent. Okay? This is still covalent. Okay? These are forces of attraction. I want you to think of these as magnets. These are not bonds. Okay? These are like stickies. They don't actually form a bond. They like stick together. Not like a bond. All right. The first one is called dipole-dipole. And I will tell you now, I am really oversimplifying this. But for the purposes of a first-year chemistry class, this is really all you need to know. A dipole-dipole force is an attraction between a polar or between polar molecules. Hydrogen bonding. And I don't know why it's called hydrogen bonding because you're not actually forming a bond. Is an attraction between hydrogen and a lone pair of electrons. And London dispersion forces are attractions between nonpolar molecules. No, we're in better shape than I thought we were. We might be able to get through this today.
I'm saying that we get out of 11:30.
How are you going to get your prom tickets if you get out at 11:30? If you can't get them till lunch.
No, I'm talking about get out of this class.
Oh, 11:40.
So they give them out at your
What's that
specific.
say?
I don't know how they're doing it.
London
I think
dispersion.
they're just doing it over all lunches, but I mean, it would come during your
London
lunch.
dispersion.
That's what I would say, because like they said that after school.
Jane, is that what it say?
But I feel like most people are gonna get there during first lunch.
I don't think she's doing it during first lunch, because that's how she did the shirts and stuff, she already did during second and third.
She probably won't do it during first.
Cause all first lunch is fresh and three.
First.
All right, is everybody caught up?
Cause that's why she said we could leave until after 12:30.
I don't even do I ever have first. Yeah.
Freshman year,
First
First
semester,
semester, that's on somebody.
but second semester, I think I had.
I had third.
Third.
yeah.
I think I still have first though.
No, I had first. I had first all freshman year, and then last year.
No, I had
Third.
second, because we had Jessup for third period, second semester.
Oh, yeah, second.
Yeah.
I hate how.
I hate having second lunch too.
I hate having that break in the middle of
I love
class.
second lunch. I hate third one.
I don't like to.
Second one is horrible.
All right, we caught them down? All right, so what are we going to do with this crap I just made you write down?
I don't know.
All right, and this is our first response on the test. I can't remember. There might be a stray multiple choice question, but most of it's for response. All right? Rank in order of increasing bullet point. Okay? So, let me pick out some compounds I like. Let's go with water. Let's go with Ki. Let's go with Cl4. Let's go with Fe.
Is this separate?
5. I need one more. Let's go with SO2.
Is this separate from what we were just writing?
Huh?
Is this separate?
Yep. No, this is what we were just writing. This goes with it. That's why I said a minute ago I'm in better shape than I thought I was time-wise. All right. So, we should be able to do at least one example before y'all leave. And then I'll have everything covered for the test. Test is Tuesday, by the way.
Oh.
All right. So, if we look at this, and we want to put these in order by bullet point, what's the first thing you think we ought to do? Any ideas?
Look at the D block.
Look at the D block. Okay. Highest bullet point was D block. Metals. Okay. Based on the properties we just talked about, Xavier's on the right track. Metals have the highest bullet point. So, what do we know? Okay. So, the first thing I would do is find bond type. Okay. Who has the greatest bond? The metals, right? Who's the next greatest bond? Ionic. And then who is the less? Remember, you don't have just elements, so you got to branch out beyond just the elements. If you just had that, then yes, we could go with that if they were all just elements. You could do D block, P block, group 2, group 1 if you just had elements. But since you have compounds, you can't do that. All right, so since we have compounds, metals are the greatest, or metallic bonding. Let me put it that way. And then ionic, I heard. And then who? Covalent. So, what can you tell me about H2O?
It's a covalent.
And what can you tell me about Ki?
It's ionic.
And what can you tell me about?
It's a covalent.
And what can you tell me about Fe?
Metallic.
And what can you tell me about SO2?
Covalent.
All right, so who is the greatest up here? And who is the next greatest? And then we're what?
H2O's.
So we're sort of screwed after that, right?
Yep.
Because we got 3 of them that are the next greatest. They're all covalent. So what are we going to do with that if we've got 3 of them that are all covalent? All right. Well, we can't go with the electronegativity chart like Stephanie said. We've got to use these. So who is the greatest of these? Most people think that, but it's actually hydrogen bonding. All right. This one is the greatest. Hydrogen bonding is the strongest.
Why'd you put them in order?
I don't know. Oh, Ms. Wells just sent an email. We will start tickets at noon. Popped up on my watch. It doesn't have the whole email. That's just the first line.
So 12 o'clock.
Well, hold on. Let me go read the whole email. But it said noon. That's 12 o'clock. Let me read the whole email. All right. Who's the weakest of those?
One.
I'm going to get my eyebrows done.
Dipole.
Because these eyebrows, they're looking like.
Apparently, that was the sum of the email. We will start tickets at noon. So that's all I got. Noon is 12. All right. Who's the weakest?
Dipole.
Nope.
London dispersed.
First.
Yep. These are the weakest. Now, these are only for what kind?
Covalent.
So, we have to figure out which one of these the covalent compounds have. Okay? So, in order to figure that out, you have to know, oh, polar, I'm a dipole. If I'm nonpolar, I have London dispersion, and I'm the weakest. If I have a hydrogen and a lone pair, I'm the what? I'm the strongest. So, how am I going to know if I have a hydrogen and a lone pair and I'm the strongest? I have to draw the Lewis structure and figure it out. Okay? So you've already told me, okay, I know that iron was the greatest, and I know that Ki was the next greatest, but the other 3 were a mystery. So I have to do the what? I got to draw the Lewis structure. Stop worrying. I'm going to do it for you.
So the next one is going to be CCL.
So you got water. You got CCl4. Stop worrying about Walmart and the eyebrows right now. You're getting out at noon, probably. Because you got to know who's got dots and who's polar and who's nonpolar.
Oh, that's long.
Because you can't use the electronegativity type because you're not finding the bonds, you're finding the molecule, right?
Yeah.
What was the other one I had?
SO2.
All right, SO2.
Yes. Oh, so you forgot an O.
Okay. So, what can you tell me about CCl4? Is it polar or nonpolar? All right, Jade, hush. What's SO2? What is H2O? All right. So, whoever has hydrogen bonding has to have what 2 things?
They have to have H2O.
It has to have hydrogen and it has to have what?
Lone pairs.
So this is the only one with hydrogen. It's the only one with a lone pair. That has hydrogen bonding, which makes it the what?
The greatest.
It's the strongest. Of these 3, it's the strongest. It has to have the highest boiling point out of these 3 because it has the hydrogen and the lone pair. Okay? That's how you decide out of the 3 covalents that it's the strongest. It has the hydrogen and it has the lone pair. Now, sometimes it might have a hydrogen, but it doesn't have a lone pair. That's why you have to draw the Lewis structure. So that means the hydrogen goes here. Now, for the last 2, who's stronger? The polar or the nonpolar?
Polar.
That's right. Because if we go back to the rules, the nonpolar was the what? It was the lowest. It was the weakest. Whoops, wrong way. So that means that SO2 is here, and then the weakest, or the CCl4, which was nonpolar, goes there. Now, we're going to practice that a little more on Monday, but that's the end of the stuff that's on the test. This was where again?
Somewhere.
Free response. It's not a multiple choice question. Now, your homework this weekend.
Oh.
I got the boot. We don't have time on Monday to do 4 review sheets. I'm gonna give it to you two. And that's gonna give each other. Okay? I'm telling you now. I'm not checking it. Okay? I will not be checking it. We will most likely not spend an hour and a half on review. Just putting that out there. We will move on to the gas laws at some point, probably halfway through class. So, if you don't start it, are you getting all of your time for reviewing class?
No.
The test is 79 questions. It is historically one of the lowest scoring of the semester. I don't anticipate that it's going to be much different this time. Some of you didn't. Some of you did not do incredibly well on the first test. Someone in this room hasn't made up the first test. So, if Darlene.
Hey, she just put you out there.
Yes, I did. I'll be here Monday and Wednesday, Darlene. All right. If you need to improve your grade, too. If you need to improve your grade,
I don't have one of them.
which one don't you have?
I have this one.
You want that one.
I don't have this one.
If you need to improve your grade, try studying some this weekend.
Right, I didn't know one more.
You get mad for the loss.